Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the quadratic relations part of the course. It's video number 11 on a series of videos where I take up some word problems that I've assigned you, and it deals with question 11. So let's go ahead and look at that question. It says a football is kicked into the air. A nice projectile question. So a football is kicked into the air, its height in meters h after t seconds is given by this formula. So it seems like this is going to be a pretty straightforward projectile motion quadratic question. And again, before we read A, B, C, D, let's actually concentrate on what the formula looks like and what we're supposed to do with it. So here's that formula in isolation. Remember, h represents the height of the object and t represents the time that it's in the air. So what do we know? Well, first of all, this equation is given to us in vertex form. And we've been doing a lot of questions. If you've looked at the other videos, we've actually done a lot of questions where the equation was given in standard form. This one's in vertex form. So we have to be careful not to, you know, we have to be careful that we've noticed that, because if you don't notice that, things are going to go very strange very quickly. So what do we know? Well, again, if we're in vertex form, we know where the vertex is. So we look at the h and the k values. So remember, it's t minus h squared plus k. And the minus sign in the formula tells us that this was actually minus positive 2 plus 4. So again, so the vertex is 2.4 comma 29. And it's a negative parabola. So here's the situation. Time and height. We have some sort of object kicked into the air. And this time, I don't know exactly where it started, and I'm not sure if it hits the ground. I'm guessing it does. But we do know that it gets to a maximum height at the vertex. So in other words, we already know that the maximum height is 29 meters, and we know that it took 2.4 seconds to get there. And without doing any other math, that's all we know. Okay, so remember, this is not a standard form equation. That's a vertex equation. So now that we've done that, let's go ahead and take a look at the actual questions. So the first question says, what was the height of the football when it was kicked? Now, be careful. We have dealt with so many questions in this form, again, standard form, that we're really used to just looking over here and calling that the starting position. And we're so used to doing that that it's probably, for many of you, instinct to look here and say the starting height is 29. But we can't do that. This is vertex form. It's not standard form. In order to find the starting height, oops, I don't want yellow, we have to let t equals 0. Because remember, starting height is the starting position, and start is when t equals 0. So unlike standard form, we are going to have to do some calculations, oops, to solve the first question. Where is the starting position? So I substitute t for 0 and now use my calculator and my bedmas skills. So 0 take away 2.4 is negative 2.4 squared. Oops, where'd that 9 go? Okay, so now in my calculator, I'm going to square 2.4. So 5.76. And then multiply these two numbers together times negative 4.9. Oops. Fix my calculator here. Okay, so I get negative 28.224 plus 29, and we can now tell that the starting position of the football was at 0.776, or let's just say 0.8 meters above the ground. So obviously, this is why we don't round too early. If you had really started rounding, even here, then you might not have gotten 0.77. And this, if you had rounded this too much, you might have an answer like 1 or 0. So that's why we have to be cautious about rounding too much. Anyway, let's look at the next part of the question. What was the height of the football after 2 seconds? At what time did the ball return to that height on its way down? So here's the scenario. I know a little bit more. I know that we start at 0.8 meters. We go up, we come back down. We know the height is at 29. But what we're trying to find out in this question is after 2 seconds. So after 2 seconds, what was the height of the ball? So if t equals 2, what's the height? And then once we know the height, we can find another number over here. So when the ball is coming back down, it'll reach the same height. So the first thing we're going to do is we're going to let t equal 2 and figure out what height that is, and then we'll see what we can do with our answer. So again, just like we did in the previous question, we do a substitution. We're going to let t equal 2, sub it into the equation, and then just do the math. Oh, a little bit of silence on the podcast. Never heard anyone. Actually, you probably can't hear it, but I have some pretty good music in the background. That's what I'm listening to, and you're probably listening to dead silence, um, or me, saying wonderful math type things. Okay. Oh, look what I did. Okay. Beep, 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 beep. That never happened. Yes, I know I could press pause while I do these multiplications, but, it's also fine. Boom. Okay. So I got a height of 28.2 meters. So after 2 seconds, um, the ball was 28.2 seconds. So let's interpret this and make sure it makes sense. 28.2, I mean, my diagram here isn't exactly accurate because 28.2 is actually much closer to the vertex. Does it make sense that we're really close to the vertex? Well, remember, that vertex occurs at 2.4 seconds. So at 2 seconds, we're pretty close to that axis of symmetry, which means that we should be pretty close to the height. So that answer makes sense to me in relation to what we already know. It's my diagram that was probably a little bit off. So we now know that after 2 seconds, the height was 28.2 meters. And then it says, at what time did the ball return to that height on its way down? So I'm going to go a little bit lower on the page, and I'm going to try to draw a slightly better diagram. So we know that it started at 0.8. We know that it went up and came back down. We know that there's an axis of symmetry right here at 2.4 seconds. And we know that, I'll use green, we know that at 2 seconds, it's at a height of 28.2. So what we want to know is, on the way back down, so it goes up, it hits 28.2 seconds, 28.2 meters, it continues to go up in the air, maximum, comes back down, and here's 28.2 meters again. What time would this occur at? Now, there's a couple different ways that you could answer this question. Certainly one way is to take 28.2, sub it into the equation for h, and solve. One of your answers should be 2, and the other answer will be what we're looking for. But there's a logical way of getting an answer, and that's based on the symmetry that we know exists in every parabola. So this point here, which we can call 2 comma 28.2, is exactly 0.4 units or 0.4 seconds from that axis of symmetry. And because of the symmetry, if I go 0.4 seconds the other side, I'll find this symmetrical point. So if 2 seconds is 28.2, then so is 2.8. Because if I subtracted 0.4 of a second, I can add 0.4 of a second. And again, you would get the same answer algebraically if you subbed 28.2 into the equation and solved. But sometimes it's nice to be able to get an answer without doing all sorts of algebra. So I hope that made sense. So let's look at the next part of the question. What was the maximum height reached by the ball? Oh, well, this one's easy. We know that as soon as a question asks for maximum height, we look at the vertex. And in this case, no algebra required. We know the vertex is at 2.429. So the maximum height right there, 29 meters. That's the nice thing about having vertex form. When did the ball hit the ground? Okay, so let's think about what we know. We know we started at 0.8. We know that at 2. We know that we know that in 2.4 seconds, it was at a maximum, but we want it to hit the ground. So be careful. It's not just 4.8 seconds. So you can't take 2.4, double it, and tell me the answer is 4.8. The reason why is because I didn't start on the ground. I started here at 0.8. So according to symmetry, if I just double 2.4 seconds, I'll be at the symmetrical point to where I started. So if I started at 0.8, I'm going to be at 0.8 meters at 4.8 seconds. So that's not the right answer. That answer, I know that it's going to be sometime a little bit after that, but when exactly? So I'm going to have to do some calculations here. I'm going to have to let h equal 0 and actually do some math. So let's go ahead and do that, and I'll just give myself some room here. So we're going to have to calculate by letting h equal 0. Oh, red, sure. And then we're going to solve. So how are we going to solve? Now, one option, and I don't think it's a good one, but let's just talk about it anyway, is you could go ahead and do FOIL on this bracket, do bedmiss and collect like terms, turn this into a standard form equation, and use a quadratic formula. But it's already in vertex form, and there's a way that we can solve if it's in vertex form, and that's by isolating the variable. There's only one variable, t, and we can isolate it by getting rid of all of the other math. So let's subtract 29 from both sides. And then we're going to need to divide both sides by negative 4.9. So that's calculator, 29 divided by 4.9 is 5.92. So now I need to undo that square. And you should remember that to undo square, you do square root. And whenever you take the square root, you should get 2 answers. So in your calculator is going to tell you 2.4. But you have to remember that it's plus or minus 2.4. And I'm going to take another decimal just because, 2.4 is already here. So let's be a little more precise, and we're going to say 2.43. So now we're going to split into 2 different answers. One answer is going to be positive 2.43 plus 2.4, and the other one's going to be negative 2.43 plus 2.4. So here I get an answer of 4.83 seconds, and here I get an answer of negative 0.03 seconds. And so again, if we think about that diagram I had, let me recreate it. So that negative answer represents the impossible part of my parabola, which exists below time equals 0. So somewhere over here is that negative 0.03 seconds. Here, the symmetrical point, about the midpoint, is 4.83 seconds, and so that's going to be my answer. That's when the ball hits the ground. Remember, it's just slightly later than that 4.8 number, which is when the symmetrical to the start was. So I hope that makes sense. Again, the important thing about this question is to be careful to make good note of what type of equation you're given. Yes, in this unit we have used an awful lot of standard form equations, but that doesn't mean they're always going to be standard form equations. So make sure you're always paying attention and focusing on the equation before you focus on the math. Okay, so there's question 11. Great, another video done, and I'll see you at question 12.